All right, this is Notes T Part 2, and we are looking at vertical asymptotes. If you just finished watching Part 1, we found some vertical asymptotes algebraically where we set the denominator equal to 0 and solved for x. Now we're going to look at from a graphing standpoint. So when we have a graph with vertical asymptotes, they're typically going to be drawn in with vertical dashed lines. And remember that vertical asymptotes always come in the form of x equals some number. Be aware, though, that if you put a rational function into your calculator, for example, you're usually not going to see those vertical asymptotes in your calculator itself. It's actually going to kind of look more just like a little gap in the graph. So just be aware of that, that's all. In this particular rational function graph, they do have the dashed vertical lines in there. So that's how we're going to visually identify where our vertical asymptotes are. And they happen at x equals -3 and at x equals 4. And remember, that's that same format we need to write our vertical asymptotes in. So our two vertical asymptotes are going to be just that, x equals -3 and x equals 4. Boom. Now, sticking with the same graph, we want to determine where this graph is positive, -0, and where it does not exist. These are all things that we've looked at previously with our graphing, but for example, in the past we did one with a quadratic function or a cubic function. Now we're specifically looking at it with rational functions. Keep in mind, though, that the process or how to find where a graph or a function is positive has not changed. So if I want to find where this graph is positive, where it's greater than 0, I am looking above the x-axis. If I want to find where this graph is negative, where it's less than 0, I'm looking below the x-axis. If I want to find out where the function actually is 0, I'm looking for where it is on the x-axis. And if I want to find out where it does not exist, that's where I'm looking for those vertical asymptotes. Okay. So let's go through the process. First thing up is where this graph is positive, where it is above my x-axis. So I'm going to highlight that area for us. And let's talk through what we've got highlighted. In that first segment, we are going to be looking at the x values from -3 to 3. Now, keep in mind, when I write the interval where the function is positive or negative, I'm always going to look at the x values. Okay. So in that first segment I have highlighted in yellow, we are looking from -3 to +3. Let's talk about brackets versus parentheses. At -3, I have a vertical asymptote. My graph gets closer and closer and closer to -3, but it's never actually going to touch it, so it gets a parenthesis. My +3 is also going to get a parenthesis, but for a different reason. This one gets a parenthesis because I only want where it's above the x-axis. I only want where it's greater than 0. Because there's no equal to, this one only gets a parenthesis. Now, in that second piece, we're going to join them with a union symbol. We are looking from 4 all the way to +infinity. So that graph's going to keep going to the right. 4 gets a parenthesis because we've got that vertical asymptote, and infinity always gets a parenthesis. All right, let's look at where we are negative now. So now we are looking from -infinity to -3. And again from 3 to 4. Negative infinity always gets a parenthesis. We're going up to -3, which is where that vertical asymptote happens, so we get a parenthesis. We're going to join that second piece with a union symbol. We're going to put a +3 with a parenthesis, because it's not equal to. And we're going to go to 4, which also gets a parenthesis because of that vertical asymptote. All right, where does this graph equal 0? Where is it on the x-axis? There's only one place on this graph, and that happens right where x equals 3. If there were multiple places that it was on the x-axis, we just write a list separated with commas. And the last part is, where does it not exist? Where do those vertical asymptotes happen? At x equals -3 and x equals 4. There you have it. You've got where the graph is positive, where it's negative, where it's 0, and where it does not exist. Now, sticking with the same graph, we want to decide through what x values does this function change signs from left to right. Sorry, let's fix that. Okay, so what that's asking me is, where does it change from negative to positive, or where does it change from positive to negative? So in the previous slide, we said from negative infinity to -3, this graph was negative. It was below my x-axis. From -3 to +3, we said it was positive. It was above my x-axis. From 3 to 4, it went back to negative, and then from 4 to infinity, my function was positive. Okay, so through what x values does this function change signs from left to right? So we're reading this graph from left to right just like we would read words. So the first x value we come across where it changes signs is going to be at the x value -3. It changes from a negative to a positive. The next x value that we come across the signs of our function changing is at +3. Here our graph changes from positive to negative. And that last x value where my sign changes is going to happen at an x value of 4. And my graph changes from negative to positive. Now, it's important to realize that these x values made the list for different reasons. -3 and 4 both made this list because those were x values where my graph changed from positive to negative or negative to positive, but they were x values where the graph didn't exist. So D and E, there was a vertical asymptote there. Whereas 3 made that list as an x value where my graph changed signs because it was a 0. It was where my graph touched that x-axis. So there's two different qualifications we have going on here. It's important to realize that both are important and both are going to make that list of where the function changes sign from left to right. Now, a rational function, two criteria we just talked about, will only change signs through x values that are zeros or through x values where the function does not exist. So the function is D and E, and that happens where we have those vertical asymptotes. Thinking ahead, this is a good thing to know. In general, these x values are what are called critical values. Or critical numbers. So that's just a good thing to kind of keep on your radar for future math. But those x values where my graph changes signs from negative to positive or positive to negative, where the x value equals 0 or the x value does not exist, those are called critical numbers.